everyone, I'm Bruce. Today I'm going to talk about a problem on Leetcode called contains duplicate. Number 3. The description of this problem is here. Given an array of integers, find out whether there are two distinct indices I and j in the array, such that the absolute difference between numbers I and numbers j is at most t, and the absolute difference between I and j is at most k. So in another way to say this problem is, so find a pair of numbers in this given array. If their value differences of these two numbers is smaller than t, and their indices difference is smaller than k, then you should return true. If you can find any pair of numbers, their indices and values satisfy both conditions, then you should return true. And if you cannot find such answers, you should return false. So here you can see we can find a 1 and a 1 here. And their indices difference is 3 and 0, which is 3. So it satisfies first condition. And their value differences is 0, which also satisfies this condition. So we should return true, right? And the second example, 1 and 0, their indices is absolute difference indices difference is 1, right? First satisfy first condition, and the value difference is 1 because the absolute value of 1 minus 0 or 0 minus 1 is 1, which also satisfies second condition, smaller than t, smaller or equal than t, right? So we should also return true. However, for the third example, we cannot find any pair of numbers satisfy the both condition. You can try it if you don't believe me. So we should return false. So how to solve this problem? So the naive solutions is to look at a window of size k. For example, k equals 2 here. So we look at a window of size, look at a window of size k plus 1. K equals 2. So we can look at the first 3 numbers because the indices of these first 3 numbers is 0, 1, 2, right? So any pair of numbers in this window must satisfy the first condition. And what we need to do next is to compare any possible pair of numbers in these windows and check if their value difference is satisfied the second condition or not. If we can find such a pair of numbers satisfy the second conditions too, then we can return true, right? But if we cannot find any pair of numbers satisfy these two conditions, satisfy the two conditions, then we just need to move forward our window to here, right? Then we continue to move our windows and trying to find any pair of numbers that satisfy the second condition. If we cannot find any answer satisfy both conditions, we return false, right? But these naive solutions it's quite expensive because moving the window forward, you need ON complexity, and to compare the pair of values in this window, you need k to the k square complexity. So in order to save this, reduce this complexity, we can use the set when we looking at the pair of values in the window size. So when you use set, we actually calculate a lower bound and upper bound of the numbers. So when we insert a new number in this set, we just calculate the lower bound and upper bound of this value based on the based on t, based on t. So um, we look at um, we look at the other values in this window size and check if any values that fall into this lower bound and upper bound. If we can find such values, if we can find such numbers, it means the absolute difference um, between these two numbers in this window satisfy the second condition, so we can return true. So we can return true. So how to calculate the lower bound and upper bound? So lower bound is actually the current number I minus t, and the upper bound is current number I plus t. So this is lower bound of upper bound when you when you inserting a number into the window size. And here is the code to check if any other numbers in this window satisfy this lower bound and upper bound. If we can find such number, we return true. So after that, we insert these numbers into the window. So, for example, take the third input, for example. When 1 is coming, so my set is empty at the beginning, right? So I is smaller than k. So we just calculated the lower bound, upper bound, because currently in this set we don't have any values, so this condition must be false. So we just inserted the first numbers. So we cannot find any other number in the set to compare with. But when we have another value coming, we calculate the lower bound and upper bound of 5. So 5 minus 3 is 2, and 5 plus 3 is 8. So the lower bound is 2 and the upper bound is 8, right? And so we're trying to find if any other numbers in this set satisfy this lower bound, upper bound, because we insert 1 at the beginning, right? So however, 1 does not satisfy this bound range. So we cannot we didn't find this. So 1 is not a solution. So we just insert 5 in this set. So we have 1, 5 in this set, right? And then we consider 9. So 9, when I equals 2, is still not greater than k, so it's still in the first window. So we calculated the lower bound and upper bound of 9, which is 6 and 12, right? 6 and 12. And we look at the set. When we look at the set, if we can find any numbers satisfy this range. However, 1 and 5 in this set, they both cannot satisfy this range. Then we just insert the number 9 into this set, and then we consider another number 1. So however, 1 is the indices of 1 is 3. So it is beyond the first window size. So we need to erase the first number 1. So it's like we move the window size from here, to here to here. So we calculate the lower bound and upper bound of 1 and continue to find if 5 and 9 satisfy this condition or not. If it satisfies this condition, we return true. Otherwise, we insert this value into the set. So we'll repeat this process until we find any answers that satisfy this bound. If we didn't find anything, we just return false. So that is the basic idea. Because we use a set, it can automatically sort the number in this set. So it saves us sometimes to compare all the possible number of combinations. Yeah, that's the solution. Thank you.